Hello students, so this is the Excel sheet or the .csv file that we have got. In this .csv file, some of the initial data of Metravi DSO is given. Other than that, the waveform that we have taken out in channel 1, which is measured in volts, is given. It's always given in volts. If it is some 0.000 something, that means it is in millivolts. Similarly, if you look at the seconds, you can see that it is 0.00006 seconds, which is actually 6 milliseconds. Okay, so the first thing that we have to do is, what I do is, I first try to convert this into milliseconds so that I am able to process this whole thing very easily. So first what I will do is, I will insert a new this, and then here I will write milliseconds, and to convert this into milliseconds, all I have to do is I have to multiply this, I have to multiply this value with 1000 because it is milliseconds. Okay, so now I have got 0.6 milliseconds, so I will pull it down for the whole set. As you can see, there is close to 3000 data points. There is close to 3000 data points. Let me just, okay, so these are the time and the voltage signal. The first thing that we have to do is we have to plot it. So what we do for that is, we select the voltage values. So I will select it for the whole 3000 values that has been given. So as you can see, it is going all the way up to 3000 values, and then I am going to insert, and here I am going to take the line plot. So as you can see, directly I have got the line values. See, the y-axis is basically having these values, whereas the x-axis is actually showing the values from 1 to 3000. That is not what I want to have. So what I will do is, I will basically, the first thing that I will do is, I will select the data, and I will click select data. So you can see the legend entries, that means in the y-axis, series 1, I have selected this particular column, whereas in the second one I have got basically from 1 to 3 all the way up to 3000 data are there. So that I want to change, so that I will take, and now what I will do is, I will basically take these values in this particular column, which is the time in milliseconds. So I should not mistake it. These are the time in milliseconds. So let me select the whole. As you can see, there are 3000 data points. That's why it is taking so much of time. Okay, so this is what I have taken. So now the data points are different. Okay, so now you can see that this is the time value, but I don't want to clutter my screen with so much time value. So again I will go here, and then I will go for format axis. The format axis, the axis option, first thing is interval between labels. That means in this x-axis, the values that I have written, I will do one thing. I will write, since I have got 3000 points, I will better write that I am going to have one among the 200 values. So the first value will be written, okay, and then the second value like that. Let me see. So as you can see, the number of values have reduced in the x-axis. Now if I want to reduce the number of decimal points, I can do so by basically clicking here. Yeah. So now you can see in the x-axis I have got very few points. Now the waveform is having a big thickness, so what I will go and do is I will go for again format data series, and here what I will do is I will go for the line color, solid line, yes, and line color I will go for, let's say I will go for this color, the brown color, and then I will basically have the marker line style to have a lower value, the line style, sorry, also to have a lower value. So you can see when I reduce the value, so now you can see that the waveform is here. I have to write this waveform. We know that this waveform is of voltage, isn't it? So the first thing that I have to do is I have to write voltage here. I will write wait, I don't think that this is the correct one. Okay, let's see now. So for changing this, we basically go and select data, and here we have named the series as series 1. So here if we want, we can change it to anything by editing it. We will name the series as voltage. So let me okay, voltage. So now the series has been named voltage, so you can see that the waveform will also be the same as voltage. Okay, now I can reduce like the number of ticks and all those things. I can reduce here by many other things. You can check it on your own, but basically this is what I want. So first thing that we will do is we will copy this and we will paste it in a Word file. So this has been done. Okay, so we have got the waveform from the file. Now next we will go for finding out the average curve. So basically what I do is I take the average of 2-3 points. So if suppose I'm just going to take 2 points, or if I'm going to take 3 points, or if I'm going to take 4 points, average of, average. So I select average here, and then I select 2 points or 3 points or 4 points or 5 points, anything. So let me select just 3 points and I close it. So what it is doing a long-term averaging. And what happens in long-term averaging is that the curve becomes very smooth. I will show it to you. So again, I will do this for the whole column. For all the 3000 data. Yes. So now that new data is the averaged out plot. So how does that work is, now I'm going to make a plot, a new plot for that, and here the plot looks the same, but actually the curves are much smooth. How? You can just go and click in the values, and what we used to do, format data series. Here the line color, I will put the line color to be black, and the line style I will try to have a very thin line. So as you can see, the graph, the previous graph had lots of noise in it, and here the noise is now reduced. I can reduce it further. By taking a higher range. Let's say I'm going to take for, let's say, 5 values. Okay, so if I have taken for 5 values, so I'm averaging out the 5 values, and since there are lots of values, it's not going to be much of a matter, but as you will see, the curve is becoming, or is having, much less noise. So now this is the smooth curve, or the smooth plot. Okay, and whatever is the noise that I want to find out, that noise I can find it out by taking the difference between these two. So I will take this minus the second value, and for the whole values, for the whole 3000 value, I will find out what is the difference between the original curve and the smoothed out curve. So you should understand, the smoothed out curve is basically by averaging the points. Okay, so now this is the difference. You can see that somewhere the difference is very less, somewhere the difference is slightly more. First, what I will do is I will rename this so we all know what we have to do. We have to look for data, select data, and select data. We will edit the name as smooth plot, smooth voltage plot. Let me write it as smooth voltage plot. Okay, smooth plot. I will again edit it. Yeah, smooth plot. Series name I will write it as smooth voltage plot. And then the horizontal axis also I have to change. The horizontal axis that we are going to use is the millisecond one. So the same thing I will take here also. So let me select the time axis. Okay. So as you can see here, again the time axis has now come, the smooth voltage plot has come. Now I can use this as a, this as a good plot, and try to find out what is the noise, and that is what we have found here. So here I will call this as the noise. Okay, this I will call it as the noise, and this one I will, again, just like what I did in the previous case, I will make it slightly bigger. Sorry. And I will again copy it, and I will paste it in the, so you can see two graphs, both of them are the same data, but one has been made smooth and the other one is having noise. Why the other one is having noise? Because that is there present everywhere, the additive white Gaussian noise. Next, what we do is we basically try to find out what is the noise here, and the noise that we have already found out is already given here in this particular group. Okay, now I have to find out some values of this one. First thing that I want to find out is what is the maximum value. So I will say what is the maximum value of that noise. So maximum value of the noise. Okay, so I'm taking the whole column and I'm trying to find out what is the maximum. So I will get that the maximum value of the noise is 0.104. Next, so this is the minimum. Next this is the maximum. Next I want to find what is the minimum value. So next I find out the minimum value. So here it should be equal to min, and in the minimum again I'm going to find out what is the minimum of the noise. Okay, so that value we have found out. Next we will try to find out what is the average value of this noise. So what we call it as the mean value of the noise. So I will just write average, simple average of the noise. So you can see that the average of the noise comes out to be close to 0. It's very. Next I will go for the standard deviation. So standard deviation. So how do we find out the standard deviation of the noise? We basically take STD, standard deviation, dot S, and again I choose the noise column and I will get the standard deviation. So standard deviation means how much it is going to vary. Now I have to plot this noise. So how do I plot the noise? So again I will choose the noise column. Okay, I have chosen the noise column and I will just go for the line plot again. So now as you can see, this is the noise that has been plotted, and you can see that the noise is more as the value of the waveform is more. I will expand this also. I will expand this one also to a similar size. Just hold on. Yes. Okay. Now here also I have to change the data. So select data. This one I will name it as AWGN noise. The AWGN noise. So you can see that the AWGN noise is there. Then we can edit and again name it with respect to the time axis. So the time axis is going to start from in milliseconds, and going all the way down. Once again I will choose 1 millisecond, and then choose it for the whole length. Okay, so we have chosen the values correctly. Okay, and then we have to change the plot line. So I will use format data series. I will go for the line color. The line color I will choose to be something, let's say blue. Okay, and then I will go for the line style, which is very thin. So as you can see that now the AWG and noise has also been plotted. So I will copy this one also, and I will paste it in this same. But now the problem is I have not mentioned, there is some issues here, so I will again some corrections I will try to make. One is that the number of time periods is quite large, so I will select that time period axis, the x-axis, format axis, and here specify the interval as I said previously, I will keep it at 200. So now the number of values have reduced there, and you can see there is a lot of noise in this one itself. I will add new data to show what is the mean line and what is the standard deviation. So both of them I want to show. So let me see if we are able to show that. For that, first thing what I will have to do is I will have to draw two values, one for the standard deviation and one for the mean. So insert, one more insert. Okay, so here I'm going to write the mean value that we had found. The mean value was this. So I'm just going to write straight away that value, which is minus 0.0001. Okay, and next I'm going to write the standard deviation. The standard deviation also we have found out here, which is 0.034469. okay, now what you have to do is you have to take both of this value and take it for the whole length, because I want to plot that also in the graph. So it is important that we do that one. Just hold on. So we will just quickly go and fill these data also. Yeah, so that data is also ready, and that data has to be shown in this particular graph, correct? So I will go for select data, and in the same one I will add the first series, which I will show it like this. Okay, and similarly I will add the second series, which is this one, that also. Okay, and now let us look at how the graph basically looks like. So as you can see here, the channel values and the noise have all got a little bit changed. Let's wait. What we will do is we will basically again go here and we will take not the format data point, sorry, we will again go here, select data, yeah, and this one we will edit. We'll take those values, but we will name them as a single value. So just hold on. So what I'm going to do is I'm going to edit this value, this name. I'm going to name it as, this is the mean. So I will just write this as the mean. Okay. The second one I will edit and I'll write that as standard deviation. Okay. Now let us see how the things look like here. So again I will format data point and memory. Okay, now we don't want this much of area here, so what we will do is we will change the y-axis, so format axis, and here the maximum I will go up to is 0.2. So 0.2. Next I will take the, again I will take the data, select data, sorry, I will go for the format data series. As you can see, we are not able to see the mean and standard deviation. That is because you can again go to select data, and if you can see the AWG noise is charted against the time, whereas the mean is not charted against the time. So here we need to edit, and we need to edit, and we will go here and we will use the millisecond. So we will choose that for the whole range. Similarly for standard deviation also we will have to, standard deviation, it is correct I suppose. Okay. So now we copy this and we paste it. Okay, so now we have got the AWGN noise. Next we have to go for the histogram of the AWGN noise. Let's go for that. So I will pull this one a little bit down because okay, so now what I need to do is I have to take the noise and I have to find out its histogram. So finding out the histogram, the first thing is that I will have to make the number of bins ready in the histogram. So what are number of bins? So I will take the maximum value, which is 0.104, and whatever is the minimum value, that is we have already got here, which is minus 0.088. So this is the minimum maximum. I will go for 10 bins. So what I will do here is I will try to find out what is the difference between these two and divide them in 10 bins. So I will go for, this is equal to within brackets this minus this and divided by, since I want 10 bins, I will write divided by 10. So this is the size of each bin. So I will take this one here and I will write the first value, the previous value, plus this change. What is the change? The change is this much, point 0.0192. Okay, so now this I will keep on going up till I reach a minimum value of, wait, this is plus, I have to go minus, sorry, yeah. So I will take this one down until I reach to minus 0.088. So let me go down. So here it has come to 0.04. No, I have to go it further down. Okay, now it has reached. Can go beyond that, but I don't want that much. I want only up till the maximum value. So this is the maximum value. This is the bin size. So I will write here, this is the bin size. Okay, next I will have to find out for what is the frequency of these values. So let me again take these out, and then I will write what is the frequency of these values. So I will write here frequency, and here I will write frequency. I will write the frequency. So what is the data array? The data array is the noise. So I will write the data array to be the whole set of noise. So what I am trying to do is, I am trying to take this noise here, and I am trying to find out what is the frequency of the data available. So that is done, comma, the bin. So the bin will be the first value. Okay, so the first value, so shift, and that I will, we'll go for the bin value. The bin value will be basically this whole range. Yes, and I will pull it down, and I will get all those values, how they are arranged in frequency. That means, and now I want to plot this frequency. So I will take this and I will straight away go for column plot, and in column plot also I will go for this one where the bins are very closely arranged. So as you can see, this one is almost having a kind of a Gaussian look. That is what I require. The only thing is that in the x-axis I want to change the data. So what I will do is, I will go for select data, and in this x-axis I will go for edit, and here I will choose this set. Okay, and then I have to find out the values. This is the frequency, so I will name this axis also. So let me choose that also, select data, and this one I will name it, I will edit it, I will name it as frequency. Okay, and the chart has now been completed, and this is the basic histogram. So let me do one more thing, and basically instead of writing frequency I will write histogram. Histogram of AWGN noise. And I will simply select this, copy, access title. If you want to change, we can change the Excel title, but anyway, and I will straight away put it here. So this much we have to do for, this much plots we have to get for one waveform. So you will find out that there is a sine waveform, two sine waveforms are there, one triangular waveform is there, and a square waveform is there. I want you to basically prepared this chart. You can save this afterwards. You can save this, and similarly you can save the Word file wherein you have made the graphs. Thank you.